In this unit, we're going to be covering different types of reactions. You will have covered these to some extent in grade 10, but we're going to revisit them again and we're going to build on our learning a little bit. So the different types of reactions that we're going to look at are synthesis, decomposition, single displacement, double displacement, and combustion reactions. So to start us off, let's take a look at synthesis reactions. Synthesis reactions involve two or more reactants coming together to form one product. So the key here to recognizing synthesis reactions is that you will only ever have one product on the right-hand side of the chemical equation. So you can see the generalized equation here, A plus B yielding AB. You can kind of think of it like this sort of relationship where you have person A, person B coming together to form a couple. Now, we've got different types of synthesis reactions. There are simple reactions where you have just an element plus an element making a binary compound. Here are a couple of demonstrations that I'd like you to take a look at. When you have a synthesis reaction, A plus B come together to form a new compound, AB. The compound has different properties than the starting materials. A synthesis or combination reaction occurs when your reactants come together to form one product. This is the reaction with iron burning in oxygen. And what we're going to do is we're going to take a piece of steel wool and we're going to heat up the steel wool and we are going to put it into a Erlenmeyer flask that contains pure 100% oxygen. So steel wool is made up primarily of iron. And so we're just going to heat that up just to sort of initiate the reaction and put it in. And you can definitely see evidence of a chemical reaction. So one of our clues there. Now, if you look closely on the sides of the container, I know it's a little bit hard to see, but you're going to see a brown iron oxide rust is formed. In the demonstration, we had solid iron reacting with oxygen gas to yield iron 3 oxide. We're going to look at the reaction between zinc and sulfur. Sulfur is a yellow powder and zinc is the more gray silver powder. And what we're going to do is we're going to mix them together in a nice little pile and we're going to try and get them to form a new compound in a synthesis reaction here. We need to initiate this reaction with a red hot iron rod, or we could heat it up with a Bunsen burner. So definitely evidence of a chemical reaction going on there. It was in slow motion. So we can see that this is a highly exothermic reaction, meaning that when the bonds were created between zinc and sulfur, it released a lot of heat energy. So this is what the product looks like, zinc sulfide. It's a white yellowish powder. So in this demonstration, we see that zinc plus sulfur come together to yield zinc sulfide. So Zn plus S yields ZnS. Now here is another demonstration that I'd like to show you, and it's actually quite remarkable. It is the reaction between solid sodium metal and chlorine gas. Now, solid sodium on its own is very reactive with water, and chlorine gas, known as mustard gas, was used in World War I as chemical warfare, and it is very toxic when inhaled. So let's take a look how these two can come together to make the very common harmless table salt.
A small piece of sodium metal is cleaned and placed in a flask filled with chlorine gas. The greenish-yellow colour of chlorine slowly disappears, and a white deposit forms on the sodium. After some time, the elements combine to give the white product, sodium chloride. Sodium chloride is commonly used as table salt. At higher temperatures, the reaction is much more violent. Sodium virtually burns in the atmosphere of chlorine. The white fumes come from finely divided sodium chloride formed in the reaction.
So this is a great example of how the properties of the initial reactants are very different from the properties of the final product. When elements come together with oxygen, we call them oxides, and they can either be a metal oxide or a non-metal oxide. So in the example, when sulfur combines with oxygen to form sulfur dioxide, this would be considered to be a non-metal oxide. When iron comes together with oxygen to form iron 2 oxide or iron 3 oxide, this would be considered a metal oxide. Now, recall that oxygen is one of the most abundant elements on Earth, and it is one of the major components of the Earth's crust, and it also makes up about 21% of our atmosphere. A common non-metal oxide is dinitrogen monoxide, also known as nitrous oxide. It is also referred to as laughing gas, as it produces this sort of euphoria when inhaled in small amounts. A major use of nitrous oxide is used as an anesthetic in surgery and in dentistry. It is also used in the making of pressurized cans, in foods such as whipped cream, and in motor racing as an oxidizer to increase the power outage in engines. So as we stated, when metals react with oxygen, they create a metal oxide. So an example here would be copper reacting with oxygen to form copper 2 oxide. So here on our government parliamentary buildings, you will see this sort of green patina, and that's because it is a copper roof, and over time it will form copper 2 oxide. When iron reacts with oxygen to form iron 3 oxide, this is commonly referred to as rust, and that's when we get that orangey kind of flaky material. When metal oxides then further react with water, we can get a secondary synthesis reaction whereby the metal oxide in the water will form a metal hydroxide. Metal hydroxides are something that are basic type solutions. And here is an example. When sodium oxide reacts with water, it will form sodium hydroxide. Because only one product is made, it is considered to be a synthesis reaction. Non-metal oxides are when nonmetals such as nitrogen and oxygen combine to form nitrogen dioxide. Nitrogen dioxide is actually a major component of smog, and you can see that especially on metropolitan type cities like Los Angeles or Toronto. On very hot days, you'll see that smog. Now, when nonmetals react, or nonmetal oxides react with water, they will create acids, so the opposite of metal oxides in water. So nonmetal oxides, such as sulfur trioxide in water, will create an acid, such as sulfuric acid. Now, where this comes into play is when we have the formation of acid rain. So here are some common acids that you will need to be familiar with: carbon dioxide, sulfur dioxide, sulfur trioxide, and nitrogen dioxide. Notice that these are all non-metal oxides, and I'm using the prefix system when I'm naming. They will produce carbonic acid, sulfurous acid, sulfuric acid, in nitric and nitrous acids, respectively. Notice that ic acids have one extra oxygen compared to us acids. So sulfuric is H2SO4, where sulfurous is H2SO3. Now, when we get the formation of acid rain, we have carbon dioxide, nitrogen dioxide, and sulfur dioxide emissions due to vehicles, burning of fossil fuels, or due to the release of volcanic emissions. When those non-metal oxides enter our atmosphere and they react with moisture in the air, in the clouds, what will happen is we get synthesis reactions that create those acids, acid rain. So here, when we get carbon dioxide reacting with water, that's what the water droplet represents, we get carbonic acid. When sulfur emissions react with oxygen, they create sulfur dioxide, which will then further react with water to create sulfur or sulfurous acid. Now, sometimes that sulfur dioxide will further react with oxygen in the atmosphere, catalyzed by ultraviolet radiation from the sun, to create sulfur trioxide. When that sulfur trioxide then reacts with water, it will produce sulfuric acid. Nitrogen reacts with oxygen to produce nitrogen monoxide, which further reacts with oxygen to produce nitrogen dioxide. Those non-metal oxides will react with water to produce nitric acid and nitrous acid, respectively. So all of those contribute to our acid rain formation. So non-metal oxides and water create acids. So here are all of the different types of synthesis reactions that you need to be familiar with. We have simple binary compounds that are formed when you just have an element reacting with an element to produce a binary compound. The more complex situations occur when you have non-metal oxides in water creating acids, metal oxides in water that create bases, and one last one that you need to know are when metal oxides react with carbon dioxide to create metal carbonates. We'll go over this in a little bit more depth in the following lesson.